purpose of this video is to introduce you to independent project number 2. This is your second independent project that you should complete by yourself without the help of classmates or tutors. If you have questions at any time while you're working on the project, you are welcome to email your instructor, who would be happy to provide some assistance. Remember also that when you're completing individual projects, you're limited to copying a maximum of 3 lines of code from internet sources. You really don't need to consult internet sources at all. Absolutely everything that you need to solve this particular problem has already been covered in class. However, if you do access an online source, please limit the number of lines of code that you include in your solution to 3, and be sure that you provide a citation for that code, just like you would if you were quoting an article for another course. In this particular assignment, we're going to be studying UPC codes. You've probably seen UPC codes on products that you've purchased. There's always a little barcode on the back and it has some numbers in it. Real UPC codes that are used in stores have 12 digits, but we're going to be processing smaller UPC codes just to get an idea of the process that's used in the real world. This particular image shows an 8-character UPC code that stores the number 1, 2, 3, 4, 5, 6, 7, 8. Even though the UPC code is usually spread across different areas of the barcode, we're going to process it as a single character string. So this barcode would represent the character string 1, 2, 3, 4, 5, 6, 7, 8. When retailers assign UPC codes, they assign a unique number to each item in their inventory. And you might think that the information included in the UPC code is all completely random, but it's actually not. The various components of the UPC code have different meanings. And so we're going to be processing some of the components of the UPC to validate it so that we can say that that UPC is or isn't a valid code. So we'll be processing UPCs to say that the provided number is or isn't a valid UPC number. Lots of different checks are used on UPC values in the real world. We're going to include a few checks in our program. The first check that we're going to consider is a check on the UPC code's length. In our fictional retailer's establishment, all of the UPC codes are always 8 characters long. Another check that we're going to perform is to make sure that the provided UPC code is all numeric and doesn't contain any alphabetic letters. So the number 1, 2, 3, 4, 5, 6, 7, 8 would be valid, but if we had a letter in there, then it would not be valid. Additionally, our retailers told us that the first 3 digits of our code always have to represent the manufacturer for a product. And the smallest manufacturer in the retail establishment's inventory is 001. It's the smallest value. And the largest value possible is 999. So we'll be able to check whether a UPC code is valid by examining the manufacturer to make sure that it falls into that range of allowed values. In our retailer, the next 4 digits represent the actual product, and in this particular project, we won't be validating those at all. The final code in the UPC number represents a checksum. It's used to validate whether the combination of the previous values is valid or not. In your assignment, you're provided with an algorithm that allows you to verify whether that 8th digit is correct in the UPC number that's been entered, or whether it contains an error. Notice that your assignment also contains sample input. You should test your program with this input. Notice that if at any time you enter input that is an invalid UPC code, the program should print out the fact that that particular code is invalid as soon as it's known in the checking process, and should not continue on with the other validation steps. Let's do a few examples. I have my finished solution here. And when I run it, the code should welcome the user and prompt them to enter a UPC code. First thing it should check for is the length. So if you enter a code that's an invalid length, your program should print a message saying that the length is invalid and should not continue on with the other checks. It doesn't make any sense to check the prefix of the UPC code or to check the checksum if there aren't even enough digits in the code itself. The next thing that your code should do is check to make sure that the UPC code contains only digits and no letters. So for example, if I enter 1, 2, 3, 4, 5, E, 7, 8, my software should tell me that that's an invalid code because it contains letters, not just numbers. And again, it doesn't bother to do the checksum in this particular case because that's not going to make any sense. If the UPC code contains letters, there's no sense in evaluating the checksum. Another thing your UPC code checker should consider is whether the code that's entered has a valid prefix. And in the project description, it tells you what the valid prefix range is, and you should detect codes that are outside that range and flag them appropriately. And again, if the user enters something that doesn't have a valid prefix, there's no sense in checking it for the checksum digit because it's not going to be valid anyway. And then finally, if all those preliminary checks are fine, if it's the right length and it doesn't contain any digits and it has a good prefix, then you should go ahead and validate the final digit, the checksum, to see if it's valid. Let's do an example where the code's not valid. If the code's not valid, it should print out a message saying that the checksum that was provided, which was 8, is not equal to the expected checksum, which was 2, and print an invalid message. If you enter a UPC code that does have a valid checksum, then it should print a final valid result. Again, lots of test cases are provided for you in your project assignment. You should make sure that your output for your code looks just like the example output in the project assignment. Be sure to check through the requirements for the project. That section outlines all of the requirements, the things that have to be included in your project in order to earn full credit. Also realize that there's a complete algorithm for how to calculate the checksum, including an example that walks you through step-by-step how to calculate a checksum value. A final important thing to draw your attention to is the fact that calculating the checksum could be really hard for some people. If you are not intending to be a software developer in your life and you have a lot going on right now, realize that the checksum code is worth 15 points of the total 100 points in the project. And so if you completely skip the checksum algorithm, but you do carefully craft your project so that it meets all of the other criteria, you can still earn a solid B on the project without even attempting the checksum portion of the project. Of course, if you're up for the challenge, then completing the entire project is a great idea. Finally, I want to remind you that in order to complete the very first phase of the project, you don't need to write any code at all. You should read through the entire project description and think about how you might design your software. In order to complete the initial IPO chart and test cases, you need to turn in an IPO chart showing your planned algorithm for the project. You should also turn in the details for 2 test cases, that's sample input along with the expected output for each of those cases. You should be able to use the test cases later on in the project development cycle to verify that your final software works correctly. However, you don't need to do that at this point in time. You're just planning your test cases that you'll use in the future.